Hello, my dear listeners. This is my probably first experience, and I want to show you one interesting mathematical problem. You see it on my sheet of paper, and the problem is to compute this definite integral as you see it in the picture, integral from 0 to pi over 2 sine to the power 2024x dx over sine to the power 2024x plus cosine to the same power. What is interesting about this problem? We see three numbers here, 0, pi over 2 and 2024. Of course, 0 and pi over 2 are kind of common numbers, nothing extraordinary here, but 2024 is some big number, and how to deal with it. It's doubtful that we can use standard Newton-Leibniz formula using indefinite integral for finding definite integral, but there is something special in this integral. Let's see. First, is it really important that the number in the exponent 2024 is exactly this number? Can it be any other number? Is there any special about 124? My assumption is that probably it's not special. We can use any number instead of 2024. For instance, just let's denote it with the letter m, and consider this integral from 0 to pi over 2 sine to the power mx over sine to the power mx plus cosine to the power mx dx. Okay. First, let's give it a name. Let's call this integral, the value of this integral, as I. Now, we have sine and cosine. The next idea, what if we consider integral, just very similar integral with cosine to the power m? What is it? How we can deal with it? We know that I just can write this formula, sine of pi over 2 minus x is the same as cosine of x. A standard formula learned from the very beginning when you started to study trigonometric functions. So what we do, we just do substitution of the variable in the integral. What we do next, just make this substitution. I can write for substitution, we introduce a new variable. Let's say t is pi over 2 minus x. Then what we will have after this substitution is usual when we deal with integrals, definite or indefinite, doesn't matter. We represent differential. dt is differential of constant pi over 2 is 0, so it's minus dx. And just change the limit of the integration. We will have integral from 0 when x equals 0. When x equals 0, t becomes pi over 2. So from pi over 2, when x equals pi over 2, t becomes 0. Now, minus dt is minus dx, it's the same as dx is minus dt. I can write minus here, and the cosine of pi over 2 minus t, because t is pi over 2 minus x is the same as x is pi over 2 minus t. Cosine, I can write cosine to the power m pi over 2 minus t divided by sine to the power m pi over 2 minus t plus cosine to the power m of pi over 2 minus t dt. I can write it here. Okay, the next step is I can write it as equals to, you know first that when we swap the limits of integration, the integral flips the sign. So it will be the same as integral from 0 to pi over 2. Now with plus the sign, with minus will flip to plus. Now this trigonometric identities, cosine of pi over 2 minus t is sine of t. So we have sine to the power m of t. Here we similarly have cosine to the power m t plus sine to the power m t dt. And of course the notation of the variable doesn't change anything. I can write again x instead of t. I can write it again as integral from 0 to pi over 2 sine to the power m x over sine to the power m x plus cosine to the power m x dx. The long thing is that the variable under the sign of integral and after d must be the same. But what we have the same integral that we started with. We started with the same integral. We called it I. So another integral is also I. So what we have two representations of the integral. I is what we had before, and I is integral from 0 to pi over 2 cosine to the power m x divided by sine to the power m x plus cosine to the power m x dx. So we have I equals this integral with cosine in the numerator and this integral with the sine in the numerator. So if we add those expressions together, those representations together, we will have I plus I to I equals integral over, now we just need to add these two fractions, sine to the power mx and cosine to the power mx with the same denominator. So we'll have sine to the power mx plus cosine to the power mx divided by the same plus cosine to the power mx dx, integral from 0 to pi over 2. And what is it? What is it? It is, we have just 1 under the sign of integral. It is integral from 0 to pi over 2, 1 dx. I can write 1, I can omit 1. And it is well known that integral of dx is just difference of the limit of integration. It is exactly pi over 2. Exactly pi over 2. You can use again the formula of Newton-Leibniz, or you can apply the geometrical meaning of the integral. 0 pi over 2 1 and we know that 1 and we know that the value of integral is the area of the between the graph of the function y equals 1 and the x-axis, and bounded by the limit of integration. Of course, it's a rectangle, pi over 2. The area is pi over 2 times 1, pi over 2. It means that 2i is pi over 2 and I is pi over 4. And you see, the result does not depend on the value in the exponent. 2024, 2025, or whatever number. Even it just didn't use the fact that the number m is a whole number. It doesn't matter. It can be any real number. Of course, we can expect that it's positive number, but it also is not important. We can use the number m can be 0 or negative. With 0 it's even easier. What we have when the number is m is 0, we would have integral from 0 to pi over 2 sine to the power 0 x over sine to the power 0 x plus cosine to the power 0 x dx. And it is the same as integral from 0 to pi over 2 sine to the power 0. Any number to the power 0, as you know, is 1. So we have 1 here and 1 plus 1. The x is integral from 0 to pi over 2 of 1/2 dx, and it is the same way as we did with 1. Instead of 1/2 we have 1/2 times pi over 2, which is the same pi over 4. And number m may be even negative, the same result, absolutely the same result. But what's interesting here, the important thing what we use here is the property. The important thing is this property that sine of pi over 2 minus x is cosine of x. Once we have this property, we can use we can write similar integrals with other functions. For instance, I can write integral from 1 to pi over 2, let's say tangent to the power m x over tangent to the power m plus cotangent to the power m x dx. And the result will be absolutely the same. It also will be pi over 2. Another example, I can write something like this. The point is, if we have expression just similar to this, if we have any functions such that for instance, f of x, if 1 of x equals f2 of say b minus x, then we can find can construct the integral from 0 to b f1 of x divided by f1 of x plus f2 of x dx. And by the same reason, if you do the substitution, b minus x equal t, and following the same instruction, the same way, we'll have the result as b divided by 2. Okay, I can leave it to you to try to compute this such type of integrals as a, let's say, as an example. As an example, I can write something like this: integral from 0 to 1, 2 to the power x divided by 2 to the power x plus 2 to the power 1 minus x dx. By the same reason, the result will be 1/2. You can try to do it by usual way. The usual way represent as writing something like 2 to the power x equals t, and represent this integral as a rational integral. You will have the same result, but here, using this property, it becomes very easy. Okay, thank you for your attention, and goodbye.